Can you see the screen?
Yes, sir.
Yes, sir.
How much time I should wait now? 2 minutes, 2, 3 minutes. I will wait again. Is it? Very few students are joined so far. Today, please sit with no, notebook and calculator, pen, etc. I will ask you to calculate few things. Otherwise, it becomes only a one-way traffic. I am only talking whether you get things or not, whether you do something at your own or not. That also should be reflected. I should know that. Okay. Once again, just confirm whether you see the screen. Example one is mentioned there.
Yes.
Right.
Yes, sir.
Okay. Good. So now we'll start. We have seen in the last lecture the procedure to solve the problems when it is subjected to some eccentric load. Eccentric also we discuss what is actually eccentric means in this context. Eccentric means the load is not passing through the centroid of this cross section. What you see here, a cross sectional rectangle, it means that if you cut this arm and see from the top, what you see is the rectangle. This is the meaning of this. In that sense, it is eccentric. It is not passing through centroid of this cross section. In that sense, this is eccentric load. Right. Now, actually, I want you to solve this numerical. To begin with, maybe 3-4 days already have passed, and you must have uh, forgot a few things. That's why first numerical I will just elaborate how to solve this. Ultimately, what you have to find out, you have to find out the cross-section dimension. Determine the cross-sectional dimension of this. Load P is given, what you see here, the load P. Little size I will change. So what the load P is mentioned here, this load P is 10 to the Newton. It is made up of gray cast iron with allowable stress. It is not mentioned which stress, but it is very you can find out, you can understand that this load is a tensile or compression load only. So allowable stress here means allowable stress, tensile stress, or allowable compressive stress. 120 Newton per mm square. How to solve this problem? If I just cut this, suppose cut means not physically cut, for the sake of convenience, I am drawing only this much part. This much means this much part only. If I draw like this, I am drawing only that much bar, suppose that column say. Okay, and if you see from the top, the section is something like this. This is a section from top. What you see is this. Dimensions are given as, this is given as T dimension, whereas this is given as 5T dimension. Now, with respect to the location of this arm, the force is placed somewhere here, right? And distance between the centroidal plane and the plane passing through this, I mean, two parallel planes, if you imagine, distance is 7.5T mentioned. Okay, so what we do, the first step is what? We transfer the force from this place to the centroidal plane or the centroidal axis. What we do? I am transferring the force from this to here. Here I am transferring the force. Now, when you transfer the force, you transfer the moment also along with the force. With respect to this force, if you try to find out the moment or bending moment about this axis for this force, it will be a anti-clockwise for this, about this axis. If you want to find out the moment about this axis, no, it will be say clockwise, sorry, anti-clockwise. So when you transfer the force, you transfer the moment also. It means this way, right? This way. Now it means that this is no more now available. Your problem becomes, of course, on the other side, you can draw a similar force here and similar bending moment also. Okay, so if I again redraw this figure, I should get something like this. This is one direct force, and this is one bending moment. Okay, this force is say now P, and this is some M. What is M? M is equal to force which you transferred into distance through which you transferred. Distance is eccentricity. So M is equal to P into E. So this is my loading now. Okay, my loading is now this one. Now you think one loading at a time. Okay. So because of this P force, what will happen? Each cross section, or in fact, each fiber is subjected to each fiber. If you take a cross section, each fiber is subjected to tensile stress. So that's why if I draw a distribution diagram, stress distribution diagram rather, I should draw this as a stress distribution diagram, right? The downward stress I am assuming as the sigma t. So this is nothing but what? Sigma t. That is each fiber. Each fiber means, for convenience, I will divide the fibers. Say extreme right fibers are say A fibers, and extreme left fibers are say B fibers. So A fiber is subjected to sigma t, and B fiber is also subjected to sigma t, same amount of sigma t, because load is tensile stress. This is because of primary loading. Now, because of secondary loading, that is because of M, what is the effect? Because of this M, if I again draw a stress distribution diagram, what I will notice that because of this moment, you can say, it is likely to bend this way. If it bends this way, this fiber, that is A fiber, are subjected to sigma t, and these B fibers are subjected to sigma c, that is compressive stress. Therefore, if I draw again a stress distribution diagram, A fiber are again subjected to sigma t, and sigma t I have taken in earlier figure as downward, that's why this is again my sigma t. But now B fibers are subjected to equal amount of sigma c, and neutral fiber will be at the center. So this something like this, I get a stress distribution diagram, right? Okay. Now, if I add these two stresses, what I come to know that A fibers on the extreme right side, A fibers are subjected to sigma t here also because of the force P, and sigma t here also because of this moment. That's why a direct addition you can do, and additional, what you get resultant is something longer. This is now addition of these two stresses on the extreme right. Whereas if you see here, one stress is sigma t, other stress is sigma c. Now, therefore, sigma t and sigma c are opposite to each other. Therefore, you have to subtract this. The net results depends on individual value of sigma t and sigma c. Therefore, you may get this type of figure, something like this, or you may get this type of figure. It depends on the individual value of sigma t and sigma c, and their subtraction is net is sigma c or net is sigma t, depending on that. This or this, you may get these two resultant stress distribution. Okay. Now, what the figure gives us the information? This figure gives us the information that at any point of time, the A fiber is subjected to heavily load. I mean, heavily stress fiber is fiber A. So it means that if you take suppose a small area of say here, this will be subjected to maximum amount of stress. And we always design a component for a maximum amount of stress, so that if we can design it for maximum amount of stress, it will be suitable for all lower values of stresses. So from this figure and the corresponding state distribution diagrams, we came to know that fiber A is heavily loaded. right? In fact, we can write down the statement here that it seems or it is clear cut, right? It is clear from the state distribution diagram. I will not write entire sentence. It is clear from the state distribution diagram that sigma t is subjected, fiber B, fiber not B, fiber A. Fiber A is subjected to maximum stress. Subjected to maximum stress. I think there should not be any doubt in your mind. Maximum stress. Okay. And what is the value of this magnitude? Value of this maximum stress? It is simply addition of these two, right? Therefore, this sigma t, which is actually at location A, which happens to be a maximum stress equal to one stress sigma t because of direct loading, the equation of which is given by P upon cross-sectional area, and other stress is because of moment, and that value is given by M upon I by Y. Both are now tensile in nature. Right. Now, this is equal to P. P is 10 into 10 to the power 3. This becomes Newton because it was given in kilonewton, divided by A. If you see A, cross-section area is given as T into 5T. That is why this will be equal to, cross-section area will be equal to T into 5T plus M. M is distance, the force into eccentricity. Force is again 10 into 10 to the power 3. This becomes Newton. This is force into E. E is eccentricity, and that is given as 5T. If you see again the figure, sorry, 7.5T, not 5T. This distance I mean, from the centroid to the point of action or line of action. This is given as 7.5T. So therefore, this is equal to I have to again change this size of this. Okay, this is equal to 10 into 10 to the power 3. That becomes load into 7.5T. This becomes what? M divided by I. Now, you have to take a very some precaution before writing the value of I. What is I? I is the moment of inertia of the section about the axis about which it is bending. So if you see from the top, this figure, this is that section from the top, what you see, which is showing. This one again, I am drawing here, right? I think we draw it here. Huh? This section, right? And if I take this as an axis, say y axis, this y axis actually in this case, in this figure, it is actually perpendicular to the screen, right? In this view, if it is seen as vertical, in the other view, it should be seen as a point. So about this, it is going to bend. It is going to bend. The section is going to bend about this y-axis. That's why moment of inertia will be equal to this t into the 5t cube whole, 5t whole cube divided by 12. I hope you understand it. Do not take 5t into t cube by 12 because about this y-axis, the section is going to bend. That's why moment of inertia t into 5t whole cube. That's why I'm writing here t into 5t whole cube divided by 12. This becomes m upon I. Why? What is y? Y is distance between the neutral fiber and the outermost fiber. Neutral fiber is now this one, about which it is going to bend, and outermost fiber is this one, right? I think it's just a minute. Huh? Okay, so since the this dimension is given as 5t, that's why this y actually becomes 2.5t. No space. So that's why this I will write here as 2.5t. Okay, this becomes my. Now, if you see on the right hand side, the only unknown is t. So you can now simplify it. Now I'll give one idea how to simplify it. Here there is square term t square. What you do, all numbers 10 into 10 to the power 3 divided by 5. You can do in calculator 10 into 10 to the power 5 divided by 2 divided by 5 becomes 2 into 10 to the power 3. Right? So this becomes actually, there is no need to calculate en because we know this is 2 into 10 to the power 3 divided by t square plus. Here also you do same thing. All numbers which you see on numerator and denominator, you separately calculate the numbers divisions and multiplication and see one number here. Put one number in the numerator. So if you see here, this is 1t here, 1t here, this becomes t square, and here 5 into 5 into 5, 125 t cube. 125 this becomes 125 t cube. So this t cube and this t is 1 t raised to power 4. So it becomes 125 t raised to power 4. And here t square term is there, t and t. So t square will get cancelled with this 2 t square, remaining is t square. This 12 will be in the numerator. What you see here is t square. Some number divided by t square. And I want you to calculate this now number. You just tell me how much number you get. I'm giving you 2-3 minutes more. Somebody can reply, please, how much is this number? I'll wait for 2 minutes. You can put on in the chat box. I'll see in the chat box what your answer. I'll also see how many of you are giving the answers. While giving the okay. $18,000, right? Okay. So 18,000, I will take it 18,000 final. So this becomes 18,000 divided by t square. Okay. And now you can now sum this. You get one number. So finally you get some number divided by t square. And what to do with the left hand side? This must be equated to permissible stress. Who will give permissible? Permissible is given by this one. This is 120 Newton per meter square. So there is no SYT and factor of safety. This rather SYT by factor of safety is already calculated, and you are given with what is the value of allowable stress. So therefore, this directly is 120 Newton per meter square. Okay, and that way you get the value of T. Please calculate the answer. What is T you get? Once you get T, if it is in say some fraction, you can round off to a next whole number. Need not be rounded off to a next even, etc. You can have a next whole number, just maybe odd number. And if you get that, what is the other cross section? Other cross you can. So cross sections will be, if this is T, the other cross section is 5T. Okay, and therefore other dimension, you can put in terms of graph, in terms of this sketch also, the dimension that is 5t will be equal to t, which is already rounded off to next whole number, that into 5 will be this much mm. This will be your answer. Can you calculate, please? Somebody in fact, actually, all of you should calculate, but I don't know. I don't know any control. You are at a remote place. I am at the far away from your place. I don't know how much faithful you are yourself. I expect you to be faithful to you, if not faithful to me. And you can find out the answer. One thing you always keep in mind in all such machine design numericals, it is my observation, it is my experience that because of lack of calculation practice, the people end up with a very wrong answer, very absurd answer. And therefore, it happens many times that students complain that, sir, I have solved of 80 marks and I got only 20 marks. The reason is that there will be a lot of calculation mistakes. And if calculations are wrong, you will not get any marks. Only 1 or 2 marks you can get for your procedure, that's it. That's why calculation is your practice, your own practice of doing the calculations is extremely important in the design subjects, in the numerical. Somebody has given answer. P is 11.26 am. Okay, it's 65 mm dimension, other dimension, right? Okay, it means you are getting somewhere 12 point something, and then you are saying that round it up to 13, and that's why other dimension is 65. Fairly correct, right? So I recommend, I advise to all of you to take part in this calculations and try yourself some calculations. I told you that you are at a remote place, you are very far away from my place, I cannot have a visual control over you. Please be faithful with you, try to solve the problems as much as possible, try to calculate yourself, this only will help you in the examination. Okay, that's good. So finally, you got T is equal to somewhere 12.9, okay? Maybe you equate it to 13 mm, okay? And that's why 5 is equal to 65 mm, right? This is the end of, see, this is a very simple problem relative to all earlier set of numericals which you are seeing, the quarter joint, the knuckle joint, the lever, etc. Eccentrically rotated joint is very, very simple to solve. Right, now, all of you, I want you to solve another complete problem and give me a solution. What is the problem? A spindle of a drilling machine is subjected to maximum load of 10 kilonewton. So this load actually is, this is P is equal to 10 into 10 to the power 3. P 10 into 10 to the power 3 Newton. Limiting tensile stress. Limiting means again permissible stress. Permissible tensile stress is 40 megapascal. 40 megapascal means 40 into 10 to the power 6 Newton per meter square. Okay, it is meter square, right? So convert this into, I don't write here now, convert yourself into Newton per mm square, because other dimension will be in Newton per mm square. Distance between the spindle and the axis of the column is 3 E. This E distance, what is mentioned here, this distance. This is distance as given as 350. So what you have to do? Simply, if I just take out this much part which is of my interest, Section is not rectangle, section is circular one. So I have to take care by writing I. This is again this way you are getting. So obviously other way also you get something like this. Force is at the right side, that's why if you take a moment it will be something like this. Again similar to this earlier problem. Okay. There are two loading now. Very much similar to earlier problem. Again, if I say that this fiber is A and this fiber is B, A fiber will be heavily loaded. Very much similar to earlier problem as I said. So what you did? In short, if I solve the problem, you'll get a sigma t. If I don't write the other thing, that is, to solve a complete problem, you should draw the state distribution. You should write that it is observed that the maximum stress is at the point A or fiber A. That's why calculating the stress only at fiber A. So fiber A stress value is P upon A. A is now pi by 4 d square plus M upon I. How much is I? I is now pi by 64 d to the power 4 into Y. Y is d by 2. M is how much? M is equal to 10 into 10 to the power 3 into distance eccentricity. That is already given as 350 Newton, 350 mm. This you equate to permissible. Permissible is given as 40 megapascal. You convert into Newton per mm square. And give me answer. Now I want the complete answer. I want the D. Please solve. This is 40 into 10 to the power 6 Newton per mm. I'm converting to Newton per mm square. Right? So again, I'm getting 10 to the power minus 6. So ultimately, you get 40 Newton per mm square only. We can remember this way that megapascal is nothing but Newton per mm square. You get on this side, you get 40 is equal to, now put all values here, please. P is, put P is in Newton. M is Newton into the distance 50, that will be Newton mm, and find out the value of T. I hope you will all calculate this. Anybody is getting the answer? Shubham Deshmukh has given the answer, it is 97.33. Amey Kadam has given answer at 97.5. Chinmay Vazhe has given answer 97.4. Nimbadkar has given again answer. Swanand Traikar has given answer. Ashutosh has given answer. Atharva has given answer. Shubham has given answer 97.3. Okay. Right. So right now B is equal to somewhere close to 97.3, 97.4. Now here, since this is not to be used further, D is not to be used further because there is no other dimension. Only D dimension is required here. No? So there's no need to round off this because you are not using it further. So let it be here, distal mm. Right? If somebody needs, you can wish, you can make it to 98, but no need actually because you are not going to use it. Okay, examiner will understand that 97.3 has got some answer, and if required, it can then can be rounded off. Next one is this one. A hacksaw frame is given. SYT is mentioned as 30. I'll read the complete sentence. A hacksaw frame is to be made of plain carbon steel 30C8, for which SYT is given as 300 Newton per mm square. The initial tension P in the blade should be 300 Newton. This is wrong. This is 300 Newton. The cross section of the frame is rectangular, which is actually shown here, with depth to thickness ratio 3. Okay, so that's why this is, if this dimension is T, the depth is always larger. Depth is 3T. Required factor of safety is 2.5. So SYT by factor of safety 2.5, you will get the allowable stress. Determine the cross section dimension. Now here I am not writing anything on the screen because it is again similar to earlier two problems. Try to solve. Force is here. Now what try to solve means what? What you have to actually find out? This is that cross section you are under consideration. This one. So you can say that I am just taking out this much portion for my convenience. This much portion for my convenience. This is that portion which I am taking out. And now the force is somewhere here. Right? Now, if you are confused with this, that which force I should take here, whether I should take a compressive force or tensile force, it doesn't matter much here because if you take a compressive force, maybe one end of the fiber will be heavily loaded. If you take a tensile load, if other opposite fiber will be under maximum load. So result will not be different. Result will not be different. But if you speak here, that if you want to put a tension, if you want to induce some tension into this blade, what do you do? You have to literally move the frame in the direction. Then only it will induce some tension in the blade. That is why a precise direction actually is this direction. With respect to this, if you now transfer the force from this to this, it will be along with this type of moment. Of course, if you want to show on other side, you can show this way. This will give you something like this. This is now M, and this is that P. Now you know how much is M. M is distance between the distance to which you transfer it. It is given as if it is not visible to you, let me write here that this distance is given as 150 mm. So P into 150 mm. P is given. So M is known, it means. Okay. So now if I give you the labelings here, that this is again some A fiber and this is B fiber. Can you tell me that which fiber is heavily loaded or heavily stressed fiber, whether it's a fiber A or fiber B? You can unmute yourself, give me answer. Which fiber, A or B, is heavily loaded? No, you are not giving any answer.
Fiber A is heavily loaded.
Which fiber is heavily loaded?
Fiber A.
Fiber A, right? Why? Because if you see actually I should write here to get it more. This is that figure, this is that force, this is that moment, and if I draw a side view of this, side view is this cross section. If I draw a straight distribution, this fiber is A, I see this fiber is B. A fiber is subjected to tensile stress, and B fiber is also subjected to tensile stress. In fact, all fibers are subjected to same amount of stress, right? So I am taking sigma T in the rightward direction. Sigma T in the rightward direction. That is why, because of the bending, again this A fiber subjected to tensile stress. That's why tensile stress here also I should represent at the rightward. And opposite to it will be then leftward. That is sigma C. This is sigma C. This is sigma T. And that is why, as Zodekar said correctly, that if you A fiber, if you add it, it will be a pure addition in the one direction only. Whereas B fiber will have some subtraction in the stresses. That's why this is result into, sorry, this something like this. This way. This is that sigma T. And what is the value of sigma T? P by A upon M upon I by Y. Now I don't write it here, just you calculate it yourself. Find out, give me the answer of T and other dimension as 3T. How much is T? How much is 3T? Are you doing or not?
Yes,
Swanand Jalekar has got answer. I should declare some rewards for you. The one who will give the first answer will be rewarded. Swanand has given answer. T is 9.116. Shubham Deshmukh has given answer 6.3. Anybody else is giving the answer? This is a very famous numerical. No, if you see last 10 papers, maybe at least 4 times or 5 times this numerical have been there in the examination. There will be definitely one numerical on the eccentric rotated joint. If you can solve this problem, you can be sure that 6 to 7 marks you got it out of, say, any mark, out of some marks allotted for opportunity. One numerical there will definitely there on the eccentric rotated joint. 6.3, you are getting some answers at 6.3. 6.3. You get some cubic equation. You have to either solve by trial error, or there is some arrangement, some functions, some procedure is there to solve the cubic equation in the calculator. Okay, so answer is 6.3. Correct answer 6.3. You can round off it. You can uh, you can avoid rounding off it. Other dimension you can get it. Okay, so P is 6.3 mm. 6.3 T is a very small dimension. No? That's why it is not rounded to 7, etc. Because you get a maximum large difference between the rounding off and the actual number. You can make it to 6.5, or you can even make it to 6.3. Let it be 6.3, no problem. Because this is very smaller dimension, 6.3 mm. If it is suppose 20.9 mm, then you can make it to 22, no problem. But if it is very small dimension, then next rounding off will again give some large difference. So you can let it be 6.3, and accordingly whatever number you get 3p, that becomes your answer. So this way you get the. Okay, here in this numerical, the change is only what that there is a cross section is hollow cross section, and therefore this will affect only in value of I. I will be pi by 64 d is to power 4 minus di is to power 4, this way. Anything remaining all will be same. Why means that m upon I by y, that y I mean. That y will be equal to do by 2. This much distance E is given as, in the numerical it is given as center of load from center of column. This is given as 500 mm. P is given as 20 kilonewton 10 to the power 3. Okay. So again, a problem is same. Only change will be there in value of I. I will be equal to pi by 64 d to the power d is to the power 4 minus di is to the power 4. Okay. And external diameter is given, so d is given. So unknown only will be di that you can find out. No, something else is also asked. Determine the stresses at the inner and outer surface. This is something different than earlier statements. What does this mean? What does this mean? That if I again take out this much portion and only redraw that much portion, equivalent diagram now this one direct force which you transferred along with the moment. This is that diagram. So again, A fiber is this one, B fiber is this one. If I go by this way, A fiber will be subjected to addition of stresses because both are tensile because of direct load and because of this moment. Whereas B fiber is subjected to some subtraction. So simply, if you see sigma T at A will be equal to P of A plus M upon I by Y. I is, I told you what is I, and both diameters are given. Y is known, M is known, everything is known. All in fact, A is equal to pi by 4 d square minus di square, that is the area. So everything on the right hand side is now known. You can get the answer. This is that inner fiber. Inner fiber means what? No. Yes, sir. This also you have to clarify. No, you have to get it clarified. What is inner surface and outer surface? Inner surface means what? Now again, there may be a confusion. Inner surface in the with respect to this C shape, inner surface actually is this one. And with respect to bending effect, inner surface is A. Are you getting this? I find this confusion in the statement. So therefore, in such cases, do not write here inner or outer, simply write sigma TA and sigma T at B. The examiner will take care of that, which one is inner and which one is outer. This will be equal to P by A minus M upon I by Y. Of course, this answer may be negative. This answer may be negative or positive, depends on the individual value of these two stresses. But if it is negative, it means, if it is negative, it means P by A, which was actually sigma T and this was sigma C. That's why only you do the subtraction. So if you get negative, this means that P by A is smaller than M upon I by Y. It means sigma T is smaller than sigma C. That is why fiber B is actually subjected to compressive stress. And when you write the answer, you will not write any sign here. Then I hope you are making it clear yourself. Because before the calculation, I don't know what is the answer, negative or positive. Once I get the answer, I can comment that the net effect is compression or tension. So accordingly, you have to write in a very clear sentence that fiber B is subjected to compressive stress or tensile stress depending on the value. If it is with respect to this equation, if answer is negative, it means fiber B is subjected to sigma C. If it is positive, fiber B is subjected to sigma T because this is more, it means P by A is more. That is the way of solving this. Now, important is this one. This is maybe we have got say 5 to 8 minutes we have got again. I try to explain this. What is this? It shows a one hanger. If you see this, this is some maybe some wall, say, on which there is some plate, right? And this is integral to this plate. And this is bracket, this is bolted to the wall. Your section is, this is the section which you are interested in. That is, one dimension is actually given as T, and other dimension is given as B. I think I have not written a complete sentence, I think. But anyway, what I do, I will, this relation T and D, this relation will be given to you. It means this is not these are not two dimensions for it. It's only one dimension for it because relation between T and the other dimension is given to you. That is not the problem. Problem is what? In the approach. That if I again extract this much part only, with respect to this, force is somewhere here, say, and that force is inclined force, which is making 30 degree with the vertical line. Now, how to transfer this force? So what you have to do, simply divide this force into two components. One component is this way now, and other component is now this one. Resolve this into two components. This is 30 degree, that's why this will be equal to P sine 30, and this will be equal to P cos 30. P is known to you. P is given as 6 kilonewton. So these magnitudes are known to you, it means. Now how they are acting here, how they will affect. So this is you can make it, instead of drawing the free body diagram, you can simply take it as a fixed one. No need to show the force here, because this is also shown here, the fix. This P sine 30 will be simply here, P sine 30. This will be that PH, say, H for horizontal. And this force, P cos 30, will be here. This is that P cos 30. Now, when you transfer the force from P cos 30, there was this much eccentricity. Here there is no eccentricity because you can see the line of action. Line of action is same. So there is no eccentricity. I did not transfer the force from one place to another place, right? I only change the location of showing it, convention. What I mean to say that I don't know whether you are getting it or not. Suppose if the force is here, I can show this diagram as this one also. No problem. These two diagrams are same. Same thing here. This force is not changed. The line of action is not changed. Same line of action I mentioned here, pH. There is no eccentricity, it means. Or I did not transfer the force through some distance. But I transfer this force through some distance, E. And E is given as, in this case, 120 Newton. Those who have got some another lecture, I will give some attendance link first. Attendance link I have given in the chat box. Okay. So now E is given to you. Now this is my net loading diagram. Along with, of course, along with what? This moment. So there are actually now, if you see, there are 3 loadings. One loading is PH, other loading is M, third loading is P cos 30. Now, if you see the effect of this, what do you see the effect of this? What is effect of effect of pH? If I ask you that question, that what is the effect of pH? Just see that pH, if you see the diagram, this diagram with the pH and this diagram actually same. Can you see this? Just I rotated the figure to 90 degree anti-clockwise. If I rotate this figure in anti-clockwise, this still remains pH. And what this is? This is a cantilever beam. And what if it is a cantilever beam, we always say that this cross section, which is nearest to the support, is subjected to maximum bending moment, which is given by pH into this much distance. And because of that, this will be a loading. This will be an effect of bending. What I see here, that because of pH, A fiber is subjected to tension. A fiber is subjected to tension, and B fiber is subjected to compression. This means that effect of pH is simply this one, this effect. This is that bending moment. Now I'll say that this bending moment is MH. MH is bending moment because of pH, equal to pH into how much distance? Maximum distance for this rectangular beam was this much of maximum distance for cantilever beam. It means this much distance for pH, and that was 250. This is given as 250. So therefore, this is MPH into 250. I think I should stop here because you have got some other lecture also, right? I will stop here. I will next time I will little elaborate on this problem, and will immediately start the next unit. So tomorrow lecture we'll start next video. We'll first complete this tomorrow, and then we will start the we'll go for next unit. Okay. So I will stop here now.